Hello! Continuing with the Conic sections chapter today by looking at loci problems, which is where you're tasked with finding the equation for a locus of points. Now, I'd like to begin by acknowledging that this is, like most of the Conic sections chapter, a topic that some students end up developing a bit of an unwarranted fear about. And that's because, okay, admittedly it is quite algebraic, but a lot of the actions we're doing in these questions are just actions that you know elsewhere from Maths A level already. And the other thing to bear in mind with locus questions in particular is there is actually quite a nice set structure that you can use as an element of familiarity with these questions. Although they almost seem presented as a problem-solving question, this structure means that actually a lot of them end up playing out the same as each other. And that's because each of them has two main stages to the question. In the first stage, when you're trying to solve the question, you're just interested in finding the coordinates of the point that the question's describing, given the particular criteria they're using. And that can be just something like we've got two lines, and you've got to find where they intersect using obviously simultaneous equations, or you've got 2 points, you want to find the midpoint of them, or anything like that. Basically nothing brand new at all, and that is all you've got to do. Again, as I've already mentioned, this stuff is very algebraic, so you've got to make sure you don't let that put you off, because it is just doing stuff you definitely can already do. And the other thing to bear in mind is because this sort of stuff has two stages, don't think about the second stage while doing this first stage. Just do, as we're talking about here, just find the coordinates. That is something we can do, and so that's all you have to think about at the beginning. But then once you have found the coordinates, that is when you can then think about the second stage, which is basically concerned with treating the coordinates now, instead of as coordinates, you're wanting to treat them as parametric equations, that you're then trying to find the Cartesian equation for. Now, to be fair, if you're a first year, you haven't come across what parametric equations are yet, so if I'm trying to word this in a different way, I'd say you end up making the coordinates as equations, x equals and y equals respectively, that you're wanting to combine almost like simultaneous equations by substituting one into the other, but doing so in a way that eliminates the third variable. In other words, you're not trying to eliminate the x or the y, partly because you can't, but the other variable, the third variable that appears in these equations, is the one you're trying to eliminate by substituting one equation into the other. Cool. So if you can compartmentalize these two stages of the sort of approach to these questions, then it makes these questions a lot easier to do. Sometimes the exam questions will treat these two separate stages as two separate parts to scaffold it even more for you, which is very nice when they do that, but sometimes you'll have to do both stages all in one big question without that scaffolding, but still the process is the same either way. So to illustrate all this, let's take a look at an example to put it into action. And to reflect what happens in an exam question, I've kind of tried to do something that usually happens, which is the locus question is not often the part A. There's often other stuff you're having to do to start the question off, and then the locus part is the final part of the question or whatever later on. So we've got a separate part A, and then our part B is the locus question. And like I was mentioning just now, in this case, the locus question is the entirety of the part B, so the two separate stages haven't been scaffolded for us. But sometimes, as I said, they will, and if they were to do that, the question would just be worded like this instead, but it doesn't really change the approach at all whether they have scaffolded it or not. You still just end up getting on with the process, and you end up approaching it the same way. So, therefore, to save room, I'm going to keep the single part for the locus question just so it takes up less room on the screen. And so, starting with part A, we need to find the coordinates of the focus, and if you remember from one of our previous videos, we point out you just got to compare the coordinates we're being given to the generic coordinates given for that particular conic section curve, in this case a parabola, that are given to you in the form booklet. Because if you do that, you can then compare them and notice that therefore, for our particular coordinates, it's implying that A must equal 6, because we have 6 lots of t squared and 2 lots of 6 lots of t. So there you go. The reason that's useful is because, according to the form booklet as well, the coordinates of the focus are then just A, 0. So therefore, the coordinates of our focus are going to be 6, 0. And therefore, we're done with part A already. Nice. And on to the part B, and this is the actual locus question now. And as I said, they haven't scaffolded it in this case, but that doesn't change the process. It's still 2 stages, and the first stage, we are only interested in finding the coordinates of the thing that they're mentioning. I'm ignoring the word locus for the moment, other than the fact it tells me it's a locus question, and I'm just interested in concentrating on finding the coordinates that they're describing. And they are describing finding the midpoint of PF, where P is the point we'd already been given in the question, and F is the coordinates we'd found in part A. So, therefore, that's all we got to do. Find a midpoint. Really that simple. So, therefore, the midpoint will be the average of the 2 x coordinates, so 6t squared plus 6 divided by 2, and the y coordinate average, which would be 12t plus 0 divided by 2. And therefore that means our coordinates simplify to being 3t squared plus 3 and also just 6t. And so there we go, that is the first stage of the process done. Although we are not done yet, it was just a case of trying to find the coordinates. They are in terms of algebra also, nothing to be worried about. It didn't really change what we had to do, it just made it look more scary while we were doing it. But now, focusing on the second stage, which is now changing how we're viewing these coordinates. We're not going to view them as coordinates anymore, we're now going to view them as parametric equations. That means we are going to write x equals whatever our first coordinate was, which was the 3t squared plus 3, and that is now an equation. And equally, we have the other coordinate leading to the equation y equals 6t. What we're now trying to do is trying to effectively treat these like simultaneous equations or parametric equations, where we're trying to eliminate the letter t. So therefore, the easiest way of doing that, being tactical of course, is just to choose the second equation and rearrange it to make it t equals. So there you go, because what we can do then is plug it into the first equation. So if we do that, we end up with y over 6 all squared plus 3. And there you go, we've found the Cartesian equation, but all we're going to want to do now for this particular question is they wanted us to prove that this forms another parabola. And to do that, we're going to want to make sure we've rewritten this equation in the format that makes it look like the standard form for a parabola. So therefore, I'm just going to do some rearranging. So for instance, we could square out the y over 6 bit, which will get 3y squared over 36. I could take away the 3 from both sides, and also of course simplify that fraction, which is y squared over 12, and then therefore we get the equation y squared equals 12 lots of x minus 3. If you want to go really overboard, you could even rewrite it as y squared equals 4 lots of 3 lots of x minus 3, because you might remember in the form booklet that the general form of a parabola is y squared equals 4ax, where a is a parameter, and therefore by rewriting in the way we've done at the end here, we have clearly shown the parameter for this one would be a equals 3. We've also got the x minus 3 there, but that's not a concern, that just means the parabola has been translated, but it's still therefore a parabola. The only last thing I'd point out on top of all this is because it's approved that question, it's a good idea to have a conclusion. So in this case, the conclusion would be something ultimately quite obvious, but it still doesn't hurt to write it. So I'd write, therefore, it is a parabola. Then it's making it super clear that I'm happy that I knew what was going on and that we are finished, and therefore that is the question done. So there you go, that is all there is to it when you're trying to do loci problems. Okay, you could have a more difficult question than the one we just had, but this 2-stage structure is consistent to all of these questions. So if you could look at this question and feel like you could have done it, then ultimately you can actually do any locus questions in conic sections, no matter how scary they might appear. Hopefully you found today's video useful, and I'll see you in a future video. Goodbye.